Welcome to Stories from the NNI. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office. Today, it's my pleasure to welcome Abby Carbone, who recently graduated from North Carolina State University with a degree in Material Science and Engineering and a minor in Nanotechnology. She'll be starting graduate school in the fall at Stanford. Abby, thank you so much for taking the time to talk with us today. Can you get us started by telling us a little bit about yourself and how you got involved in nanotechnology?
Hi, yeah, thank you so much for having me. I'm really excited to be here. I have been involved with nanotechnology kind of throughout my whole time at NC State because as a material scientist, you have to understand how things work on the nanoscale in order to understand and predict, properties of materials at the macro scale. So, I personally don't really think you can be a material scientist without at least being aware that really important things happen on the nanoscale. So I've been really lucky as an NC State student because I have gotten the chance to do so many really cool things. So for example, I did an internship at Eastman Chemical Company my sophomore year over in Kingsport, Tennessee, where I was able to make thin films for medical devices. And then the following summer, I went all the way across the country to the California Institute of Technology, and I worked on making nanoporous metals. And what we did with them is we figured out ways to, or we tried to anyway, figure out ways to turn carbon dioxide into useful chemical fuels. And then for my senior design project, I was able to do this program offered through the engineering department called the Engineering Entrepreneurs Program, or the EEP, where it was a team of me and four other people, and we started with a blank sheet of printer paper, and throughout the course of 2 semesters, we were expected to create a startup company. And our particular company made a nanomaterial where we made it ourselves in lab, and we put it into a plastic, specifically an epoxy that we bought from Home Depot. And then we shot it with a 22 caliber and a 9 mil, and we made the epoxy with our nanomaterial in it bulletproof. And then I've been very heavily involved in electron microscopy, so both scanning and transmission electron microscopes. I've worked for Protochips, which is a company that was based out of NC State, and then also at our characterization facility, the AIF at NC State, driving microscopes. So all sorts of stuff.
You mentioned your experiences, both kind of these academic experiences, working in industry, having these opportunities throughout your undergraduate career. What aspects of nanotechnology that you've encountered so far make you the most excited?
Oh my gosh, so many. I think, I think nanotechnology and nanomaterials are really fascinating because things on the nanoscale don't operate by the rules that we view in our everyday life. The physics and the chemistry that happens down there is so different from everything else that we know and we see around us. So, for example, if you have a gold necklace, we know that gold necklace is going to be gold colored, right? Because we see that every day. But if you take that gold necklace and you science it and turn it into gold nanoparticles, and you take those nanoparticles and put them in a solution of some liquid, maybe water or something, that solution isn't going to be gold colored. It's going to be like a hue of red. Something that makes me really excited outside of batteries and energy and all those kinds of things. Kind of a guilty pleasure almost is space exploration. So the professor that I worked with at Caltech last summer, he is currently spearheading a project where they are creating this thing called a solar sail, which is a very thin material where you shine light on it and the light acts as a propulsion system. So imagine shining a laser on a really thin piece of paper just for you to be able to visualize it, and the piece of paper will shoot forward. Except what he's trying to do, along with a big collaboration with a lot of folks, is they want to create a very large one of these solar sails, but is very thin and on the nanoscale. And they want to shine an ultra high intensity laser, shoot the solar sail into space, and this solar sail will travel at relativistic speeds But not only do they want to create this absolute feat of engineering, they want to shoot it to the nearest habitable exoplanet, Proxima Centauri b, and they want to shoot it to the nearest solar system. And then they want to take data using a microchip that also requires lots of nanotechnology, take spectra of data, and they want to take pictures and then send that data back to Earth and on the time scale of a human lifetime. And every single part of that process requires nanotechnology. And so I just think that is objectively cool.
Well, I would have to agree, but I would also say that your answer kind of demonstrates your passion for science and really the way that I found you, which was as host of a video series called Sciencing with Abby. So can you tell us a little bit about your show?
So I am very, very involved with outreach back at NC State, or I was. And the NNCI has given me so many opportunities working with the Research Triangle Nanotechnology Network, the RTNN. I've been able to do a lot of demonstrations. I've done stuff with the MSc department and the chemistry department and whatever. And I say that I want to be the next Bill Nye the Science Guy. It's kind of my claim to fame. So when the quarantine hit, that was a huge bummer, to say the least, because I wasn't able to go and do these demos that took up a huge part of my life. And I really missed it. I missed interacting with the public. I missed getting messy with science experiments with kids. And it kind of broke my heart that students weren't able to go to school and do these really neat experiments, because when you learn about science, you don't really, you remember the things that are in the textbooks, and those things are important because you need to learn those things in order to understand the cool experiments. But realistically, right, if you think about your experience in high school chemistry, you don't remember the hours that you spent sitting in a classroom. You remember that one time you turned a flame from a Bunsen burner blue, and you remember those hands-on experiments. And so I was really sad that students weren't getting those opportunities during the quarantine. And also, I was by myself during the quarantine, and I am very extroverted, if you couldn't already tell. So, all of those things combined, I said, I cannot sit in this house any longer just doing nothing. I have to do something. And so I set up my phone and found a bunch of random science decorations that I had just around my house because I'm a massive nerd and have lots of those. And I just kind of decided to.
It's great that something good has come out of this terrible situation. And clearly, your ability to share your passion for science, I think, comes through and is important. And I want your thoughts on science communication. You said you did a lot of outreach when you were in school. How did you get involved in science communication? Why do you think it's important?
So I actually got involved in science communication by watching my dad. So my dad teaches physics, and every year in elementary school, he would come into my classroom. And then one year he did one for like the entire grade, and he would do science experiments. And so growing up back home in Stafford, Virginia, I was born and raised there. Honestly, even to this day, I have people talking to me about, oh my gosh, I still remember that one time your dad came in and made liquid nitrogen ice cream with us. Or I remember that one time we were able to sift through all of those rocks. I'm not even kidding. Like the day I graduated, I was walking through the halls in my graduation gown and robes and whatever. And I had someone come up to me and say, oh my gosh, like you're the girl with the really cool dad. And so, I was able to grow up, watching him make all of my classmates really excited about doing this. And I mentioned that I grew up watching Bill Nye the Science Guy and the Magic School Bus. And I just love that you can get everyone excited about science by doing these demonstrations. And especially as a woman in science, I think that science communication is extremely, extremely important. One of my favorite demos to do is liquid nitrogen ice cream. And so we had an elementary school near NC State that we would go to every year. They had been doing this for about 10 years, and we were known as the ice cream people. Like we would walk into the school and we could hear, excited hushed whispers of the students pointing at us saying, oh, the ice cream people are here, whatever. So we were pretty famous, not to brag in that school, but I will never, ever, ever forget this moment. A girl in a pink sweater, when we finished our, liquid nitrogen demo and before we were about to start making our ice cream, we asked if the students had any questions, and this girl in the pink sweater shot her hand up in the air, pointed at me, and said, how come she's the only girl here?
Wow.
Yeah. Yeah. And so I don't think anything can demonstrate the importance of science communication better than that experience. And I, since then, have never questioned the importance of doing these demos. And even with not just students, but so the RTNN has a portable scanning electron microscope, and we decided to take a road trip out to more rural parts of North Carolina. And we brought it with us, and we went to this public library, and we had the microscope, and there was this older man who came up to us so excited, and he just looked at the microscope just in complete awe. And he said, I never thought that I would see one of these in real life. I have always wanted to, but I never thought I would get a chance to see one. You can't ever underestimate the importance of science communication.
I want to switch gears and talk about your favorite nanotechnology demos. And I also want to ask you if you've used any of the Nanonet demos that were developed by the Nanoscale Informal Science Education Network.
I am familiar. I have sifted through their website and looked at a bunch of their demos. I haven't gotten a chance to make a video with one yet, but it is absolutely on my radar. I would love to do one of their demos because I think they have a lot of really cool and diverse experiments on there, and all that are pretty accessible to things that you can find at home. As far as my favorite experiment, I've got two, and my two favorites are the portable scanning electron microscope, because electron microscopy is one of my absolute favorite things about material science and, about my experience in undergrad. I think that they are just so much fun, and it's really cool. Just the fact that we get to have one that's portable and we can bring it wherever we want, I think is just mind blowing. And, we get to look at all sorts of really cool stuff. So a butterfly wing and a cockroach and a microchip and, a piece of like a Band-Aid and all sorts of stuff. So that's really cool. And then I also really love the photolithography demo. So photolithography is the process of creating the components on your electronic devices. And so we have a demo that kind of details how that process works. So students can go through and kind of do a mock photolithography process. And so I think it's really cool to teach students about microelectronics, but then also they get to kind of do it hands-on.
So I want to get your thoughts in a different area. And my question to you is, when you look toward the future, where are the most exciting areas where you feel like nanotechnology is going to have an important contribution?
I think that nanotechnology will eventually make its way into every field, every discipline, every market. But specifically, the ones that I'm most excited about are renewable energy and sustainable energy. So making more efficient solar cells, making more efficient ways to harness and store energy, or coming up with ways to take carbon dioxide and turn it into other useful things, because there's an entire partnership, the Joint Center for Artificial Photosynthesis, or JCAP. I mean, it is a huge collaboration, and it's a really, really difficult endeavor just trying to answer that question of how do we take sunlight and water and carbon dioxide and turn the carbon dioxide into maybe a fuel that you put into your car. So, and I think the answer to do that lies in nanotechnology. And I think also, like I mentioned with the solar sails, going into space and exploring so many parts of the unknown is going to be possible through nanotechnology. So, and you can kind of combine those two things of how can we make it so that if humans want to live on Mars, they can do so reliably live on Mars and use renewable energy, and they can create their own widgets to make their own oxygen supply or make their own water supply or whatever, whatever it may be, make their own, regenerative ice cream supply if that's what they want on Mars. If they wanted to do that, they could do that using nanotechnology.
So, Abby, I really enjoyed our conversation today. This was a lot of fun, and I really hope to have the opportunity to work with you in the future to help inspire the students who are just getting started in their academic adventures. Do you have any closing thoughts that you would like to share with our listeners?
Thank you so much for having me. I've also, very much enjoyed this conversation. If anybody is a science communicator, or if anybody is interested in science communication, I think sometimes it's easy to feel like what you're doing maybe doesn't make a difference. Maybe you have a particularly apathetic group of students, or, maybe your spiel or experiment didn't go as planned, or maybe you spend 15 hours creating a video that only gets 7 views. But when you feel that way, I would encourage you to think about the fourth grader who asked me why I was the only girl here, or, the man who was so excited because he couldn't believe he was seeing an electron microscope in real life. Because people, and kids especially, are more observant than we give them credit for. And so if you show up and are excited and you're passionate, they're going to notice, and that will leave an impression. And I think for our younger listeners, if I have any students who are listening to this who, might be excited about STEM and about science, I would just encourage them to really, really run with that passion and with that excitement, because I promise that however awesome they think science is, it is so much awesomer once you get to college, and, if they do research or if they do industry or, any of that, it is so much more incredible than they can even think of right now. So I would really, really encourage them to really run with that passion and excitement for science, because it will pay off.
Thank you for joining us today for the Stories from the NNI. If you would like to learn more about nanotechnology, please visit nano.gov or email us at info@nnco.nano.gov, and check back here for more stories.